Okay, so we're going to look today at integration by substitution. Now, if an integral seems really tricky and complicated, often we can make that simpler by making a simple substitution. So, for example, here I have the integral of 2x over the square root of x squared plus 1, all integrated with respect to x. Looks pretty horrid. But what I'm going to do is I'm going to let u, or any other letter for that matter, u equal x squared plus 1. Typically we do use u. Then when I differentiate this thing, u equals x squared plus 1, I'm going to get du by dx equals 2x. So with some simple rearranging, I can see that dx is going to equal du divided by 2x. I can then make all of these substitutions into the original integral, and I can see that I get the integral of 2x over the square root of u times the du over 2x. So the 2x's actually cancel out, and I actually end up, hopefully you can see this, with the integral of 1 over the square root of du, or when we write it in index form, the integral of u to the power of minus a half with respect to u. Okay, now that we can integrate, okay, and we're used to integrating that sort of simple integral. So I've got this, and we know that this is going to integrate to u to the half over a half plus constant, which is to the square root of u plus c. But of course we know that we made this original substitution, so we have to substitute this back into my answer. So that integral equals to the square root of x squared plus 1 plus constant. Okay, what I'd like you to do now is try these following questions. So we have the integral of e to the x over 1 minus e to the x all squared, and use the substitution u equals 1 minus e to the x. And question 2 is the integral of sec squared x over tan cubed x dx, using the substitution u equals tan x. So what I'd like you to do is actually do those questions, pause the video, then do the questions, and restart the video once you have your answers. So hopefully you got for your questions 1 over 1 minus e to the x plus c, and for question 1, and 2 minus 1 over 2 tan squared x plus k for question 2. Now sometimes the simple substitution isn't all that we need to do. We actually need to do a bit of rearranging of our substitution as well in order to get all u's in the question. So looking at this example here, I've got the integral of x squared plus 4 over x minus 2, all integrated with respect to x, and I'm going to let u equal x minus 2. So du by dx is just 1, so du is dx. So I'm not going to get that cancelling out like we had in the previous questions and example. So rearranging my u, I get x equals u plus 2. Okay, now we've got an x squared in here, so I'm going to have to square this. So x squared is going to be u squared plus 4u plus 4. So now I can actually make my full substitution. So I substitute my x squared into here for this one, and I substitute my x minus 2 is u into the denominator, and change my dx into the du. Now because it's a denominator is just u, we can actually separate that out. So we can separate it all out, and remember that's what we do when we have a single denominator. And we can actually do some cancelling. So ultimately what it's going to come down to is u plus 4 plus 8 over u du. That's nice and simple. We can integrate that term by term. That's going to give me u squared over 2 plus 4u plus 8 log u plus my constant, of course. Now obviously we can't leave it in terms of u, so we actually have to make that substitution back. And we get, obviously, substituting wherever I see a u, I stick in x minus 2. Put it in, expand it, and simplify it, and you end up with x squared over 2 plus 2x minus 6 plus 8 log x minus 2 plus the constant. Now, most of the time you'll probably be given the substitution, but if you come across situations where you haven't been given the substitution, okay, a good rule of thumb is that whatever is on the denominator, if it has a denominator, is what we use as the substitution. or if it's under a square root or in brackets, we also use that as the substitution. So depending on the type of question you get, depends on what the substitution will be. Obviously, most of the time you'll get those substitutions, but if you don't, bear that in mind, okay, and you'll pick that up through doing the questions.